Okay, so our presentation is going to be on the macro side of Meso modeling, an ICA-based assignment case study in Hillsboro, Oregon. And if you missed my intro from Garth at the very beginning, I'm Randy Johnson, Senior Transportation Engineer at TKS. I lead our multi-resolution modeling discipline group. I'm also co-chair for the local ITE, Oregon ITE SimCap Group, which is sort of co-sponsoring this event. Feel free to reach out to me if you have any questions about SimCap and want to learn more about the events we have coming up. And then I'm also a member of the TRB Simulation Committee. And then I'll be kicking off this presentation with a little bit of background of the model development in Hillsboro and really what this sort of set of tools is. And then Kayla will be presenting on sort of the actual project applications. And Kayla is a transportation engineer with DKS in our Portland office. She pretty much does the full gamut of multi-resolution modeling from macro, meso, and micro, and really likes working on projects with a focus on multimodal solutions. All right, if I can get my slide to advance here. So multi-resolution modeling, where does DTA fit in? So Peter and David kind of talked specifically about the DTA applications. Peter provided a little bit of an overview of sort of the macro, meso, micro. And the important thing here is choosing the right tools for the project application. And that also means that you get the right data to support those tools. And with increasingly constraints on funding, policy changing, we're having to be more creative in the solutions we develop, and we need to have strong data to support those. And so how do we manage our systems when we have limited funding, limited right of way? And we want to make sure that we're doing the best investment of those dollars that we can. So we want to make sure that we're choosing the right tools. That's an important aspect here. I'm not going to go too much into the multi-res overview. Peter did a pretty good job in the first presentation. But there are many tools with many different needs, different software packages for each of these scales. And so it's important to know what are the benefits, the pros and cons, limitations of each of these software packages, and maybe what combination of tools you'd want to include. So again, recap, the macro side, generally referred to as the regional travel demand model. It definitely is at that regional scale and influence. Applications, congestion pricing, route diversion, parking cost, mode shift, transit capacity, demand development. There's a whole range of different applications. But as Peter mentioned, one of the key things is it's not necessarily capacity constrained in the way that a mesoscopic model is. The mesoscopic can be kind of fairly large sub area. It's still challenging to do a full regional scale, but there are a few applications where that is being done. And small to medium sub areas are quite common applications. But now we're getting closer to the simulation. So we can adjust some driver behavior and having detailed junction control. Dynamic traffic assignment over more discrete time periods. And so this, now that we are actually capacity constrained, we get a little bit more effective evaluation on something like route diversion. The dynamic examples that were presented, that's a lane-based DTA, but products like Dynasty, there are link-based DTA, so a little slightly simplified version of DTA. And all these are great applications for queue spillback between intersections, understanding the impacts of peak spreading or how a project may reduce the hours of congestion. And ultimately, you're going to have the benefit of faster runtime over micro simulation. So really, the concept of multi-resolution modeling here is a combination of these tools. There's a whole variety of different approaches that you can go. You know, if you're doing a detailed operations analysis, corridor study, you might go straight from that macro to the micro with some post-processing for the volume development. That's a very traditional approach. With the Hillsboro example that we're going to present, we're inserting a meso step there in the middle to introduce more refined assignment, more detailed loading of the network. And you can even go just straightly from macro to meso. That's more the application that Metro is doing with the congestion pricing. And then we don't see it too much yet, but doing the full macro, meso, micro, but getting that feedback loop back up the resolution, whether it's into a meso model or all the way back into the demand model. So there's a variety of different combinations that you can do, understanding these limitations, benefits of the different tools, and choosing the one that best fits your particular project application. So in that meso world, there's more than just dynamic traffic assignment. The ODOT APM has a chapter on mesoscopic modeling, which is really more focused on a windowed approach. It's more of a detailed subarea analysis. And so with that, you basically enhance the network. You're cutting out a subarea, so you have a fixed cordon boundary, so that demand going in and out remains sort of fixed. Generally, a lot of the regional demand models are pretty coarse in their network. And so this process generally involves adding some additional network connectivity. Sometimes it means disaggregating zones. Other times you're just simply refining the connector loading and maybe even the shares of those connectors in terms of getting the right demand to the right locations to the network. That's important when you're going to be ultimately focused on more an operations-based model. And then for our next steps and applications, we're really, again, focusing on operations. So we're adding in additional network detail. We're coding, similar to what you would do in a dynamic model, we're coding the individual lanes, but we're also, I guess, in addition, coding in the signal timing as well. So that's going to allow us to do two things here. One, we have all of the inputs for geometry, signal timing, volume. Now we could basically do HCM analysis on the fly. So that'll allow us to get our level of service, volume to capacity ratios. And so as we run through our projects, run different scenarios, alternatives, we could see the immediate results without having to then export, go into a tool like Synchro or HCS and process the information externally. So it's all sort of integrated. The benefit is we're actually using that HCM calculation as part of our volume delay function or impedance model in the assignment itself. So the assignment is responsive to if we add additional lane or we change the control type from an always stop to a signal, that delay is going to go down and it'll pull more demand in there. So while not a true dynamic assignment model, you're going to get a more refined assignment based on the operation characteristics of the net. And so that's the process that we applied here in Hillsboro. Hillsboro is actually a pretty early adopter in this. Let's see, I've been with DCAS for coming up on 9 years, and I was with PTB for about another 9 years before that. And so we started on the downtown Hillsboro modeling probably 2005, 2006. And we've used this same set of models kind of refined over time, but we've used it for about a half dozen projects in the downtown area. From looking at street vacations to conversions from one-way to two-way streets, some regional impacts. And then we have 2 projects going on right now that Kayla will be covering in detail, looking at adding a couplet as well as sort of refining and modernizing an existing couplet to add more multimodal facilities, improve pedestrian connectivity. But you can see here, this is what the regional model, how it's reflected in the downtown Hillsboro area. We've gone through, we've added in more local connectivity. We disaggregated the zones down to the block level that allowed the city to go through and do some sensitivity testing in terms of different development scenarios and basically create a build out scenario. And then other unique characteristics we have within Hillsboro is we have some major regional through routes. We have a grid network. We also have light rail that comes through with frequent preemptions. And we have queue spillback between multiple intersections with short blocks. So traffic is very dynamic in how it reacts to congestion. And you can easily kind of go around the block to get around a temporary queue buildup from a rail preemption, or to kind of stair step through the network to get around that several block queue from a traffic signal. Early on when we developed this, we actually used dynamic traffic assignment at the microsimulation level. That was, cost benefit really didn't pan out. It was very tedious to kind of calibrate that with such a tight grid network. and using 15-minute time intervals. In reality, the decisions of routing changes were done at a finer time increment than 15 minutes. So in our current iteration, we're basically pulling the refined routing from the Meso model, putting that into the microsimulation model. And then we've developed sort of localized dynamic routes. So they're sort of key diversion routes where if a particular corridor will build up, then you're going to get a certain percent of traffic that's going to take the secondary route. So we have this sort of fixed dynamic route logic set up directly in the microsimulation model FEASN. So that's sort of the general process. I'll go ahead and kick it over to Kayla to talk through our applications.
Yeah, so just a little bit of context for those who might not be quite as familiar with Hillsboro. I've got this little cloud around the downtown area, and then the orange lines represent OR8, which serves a lot of regional traffic kind of between Beaverton, Hillsboro, and then out towards Forest Grove and Cornelius on the west side. And then you also have that yellow stretch of 10th Avenue, kind of north of that OR8 section that also serves a big chunk of Hillsboro, sends you out towards the Intel campuses and the airport, and also out towards US 26. So within the downtown area, there's a lot of regional trips going through the downtown. So there's kind of two key drivers for the projects that we're working on right now. Randy mentioned we're working on two kind of separate projects, but for simplicity's sake, I'm going to kind of lump them into one here. So two of the key drivers for these projects are really, economic revitalization and re-envisioning of that 10th Avenue corridor, both the OR8 stretch and the 10th Avenue stretch to the north. And then also improving efficiency and safety for kind of all modes of travel. We'll move to the next slide, Randy. Here's just a couple quick images to give you a sense of what 10th Avenue and Oak/Baseline or OR8 look like today. So Oak and Baseline are both 3 lanes in each direction. There's pretty limited parking on Oak Street and limited pedestrian crossing opportunities with no bike facilities. If you look at 10th Avenue, it's a 5-lane corridor today. There's a lot of development that's really curb tight, no bike lanes, narrow sidewalks through a lot of 10th Avenue. And the City of Hillsboro's TSP currently identifies a project to widen 10th Avenue from 5 lanes to 7 lanes to address capacity concerns. And so that would obviously have a pretty big impact on kind of the form and function of this facility and impact on adjacent businesses. So as part of this project, we're really looking at maybe alternatives to going from that 5 to 7 lane corridor. So some of the key objectives that we were really trying to understand and why we wanted to use this multi-resolution approach is that we're really trying to understand kind of the regional routing aspect of it, right? So if we have all these regional trips going through downtown Hillsboro, are there opportunities to have those regional trips off of the downtown facilities? We also were looking at changes to local circulation patterns. So understanding that the city's grid today is a one-way network when you get towards 5th Avenue in downtown. And so if there's any changes to local circulation patterns, if that can reduce your out-of-direction travel, improve connectivity for bikes, what impact would that have on traffic operations? As Randy pointed out, the Meso model, the way we coded it, did allow us to look at that intersection operation level detail, so HCM operations, and then really understanding how we could test changes to the roadway configuration to try to see if there were alternatives to that 7-lane widening. Next slide, Randy. So at the macro level, really looking at that, trying to answer that regional routing question, we tested a couple different routes shown in the blue lines here on the screen. We were kind of throwing feasibility out of the window just to see, is there even potential to drive trips to some of these other facilities and get them off of those downtown facilities on OR8. And really there wasn't a high driver to get vehicles off of OR8. And so taking into account the limited feasibility of these routes, the cost really would not pan out. Go to the next slide, Randy. We then kind of bumped it down a level to help answer the local circulation question. So using the Meso model, we were trying to understand if you could convert either a subset of the city's one-way streets, shown in the purple there, or all of the one-way streets to two-way downtown. Again, trying to reduce some of that out-of-direction travel, giving maybe better opportunities for some bicycle connectivity through here as well. And that was a great candidate for that Meso model, where we had more of that refined local street network. We had that block by block zone disaggregation to really understand the circulation changes with this type of project. Again, the other application for the Meso model was really looking at intersection operations. So we were able to forecast the future traffic volumes using that disaggregated zone structure again, and analyze our HCM6 operations. Like Randy mentioned, you can really do that on the fly as well. So as your testing changes, you can very quickly see the impacts rather than having to bring it into a different software platform. And this also was what we used to get that routing into the microsimulation model, like Randy mentioned. So then finally, I've got a video here on the screen that just is a really quick video we put together to show the microsimulation side of things. And so like Randy mentioned, we wanted to really understand the impact of fuse flowbacks between intersections in this congested model, understand the impacts of the light rail crossings, and then still have the flexibility to do some localized dynamic routing here without going to the time and effort of getting the truly dynamic assignment. And that, again, that localized routing did allow us to have kind of that finer level of time intervals, like Randy mentioned. And so, the exciting thing, like Randy pointed out, putting development cost into tools like this. He's been working with these models for quite a while now, since 2005, 2006. And we still have additional applications that we'll be using these models for. So one of the outcomes of this project is going to be looking at selecting a locally preferred alternative and ideally a TSP amendment so that we can look at more or recommend more unique concepts. Like this is a couplet concept here for 9th and 10th Avenue that's being shown on the screen, to amend the TSP and not have that 5 to 7 lane widening impact. And then this model will also be used in part for some analysis that we're doing on TV highway, looking at BRT operations. And so those are kind of some next steps for these models in this process. If you want to switch to the final slide, Randy, I'll pass it back to you quickly.
Awesome, thank you. Yeah, and just to point out on this example, all that blue is sort of basically area that can be reclaimed for future placemaking. And so, what was in a older transportation plan of going from an existing 5-6 lane to a 7+ lane facility and wiping out a lot of right-of-way and existing businesses, where a lot of communities are kind of going away from couplets. This particular case, given the unique sort of funnel of regional traffic through the downtown, this is actually allows the city to create a better place along 10th Avenue, going instead down to 2 to 3 lanes, adding on-street parking, bike facilities, and some additional amenities. And so really demonstrating that through the operations and the modeling process here. So just kind of a quick overview of the benefits of the multi-resolution process. It's efficient and more realistic on the demand development side. Typically with you're taking future demand out of a travel demand model. There's a lot of post-processing that you need to do to really get it to that project level. And here we're kind of effectively doing that directly within that Meso step. The ICA-based assignment provides more realistic routes than macro model with lower level of calibration needed than DTA typically. And so there's a lot of benefit that you could do just simply from that. Like the title of the presentation stated, the macro side of Meso. And this even supports integration with ETA tools. So you could certainly swap Dynamic in there if you're using a different software package across the different resolutions. And the Meso to micro also saves some time on the network development if you're doing the export from the Meso to the micro. And a big thing here is one Meso model can support multiple projects. So it's not a one and done. Like I said, we've used this for over a half dozen projects over a span of 15 years. And, you know, we've got to do some updating here and there, but there's been a lot of economies of scale and savings there. And then ultimately it's a cost-effective solution for realistic and confident results. And you have not only the data to back it up, but, you know, modeling results that stakeholders, especially non-technical stakeholders, can see. So with that, we'll go ahead and close our presentation. Any questions?
Randy, this is Peter. I have a quick question.
Yeah.
For you or Kayla. How much difference did you find the signal timing plans make at the meso scale in your model? Are they as impactful in the meso model as they are in the micro simulation? Are they less impactful? Did you find that if you didn't have the actual timing plans in place, did you get markedly different model results in your meso model?
I would say it really depends on the details of the specific network. And so like in one case on Lincoln, which is just north of the downtown area, where that ties into Cornell, the route Kayla showed going up to towards Intel and sort of North Hillsboro. When we went from an unsignalized two-way stop controlled to a signalized intersection there, that actually pulled quite a bit of traffic, just because the alternate routes that are being used before were fairly congested. So again, it depends on the network specifics, but it can make a pretty substantial difference.
And similarly, because of the grid structure through downtown, there were definitely a couple locations where some minor tweaks in intersection signal timing would impact some of the routing choices with the ICA assignment.
Is that trying to like get coordination correct so that, or is it more like, I'm just trying to figure out, because from my experience, at least at larger levels, the timing plans have an impact at the individual intersections, but the overall routing, unless like the timing plan is really egregious and causing a lot of backup for a particular movement, I've found that like generic timing plans are a good first substitution, maybe for, you know, if you don't have the capability to maybe get all the timing plan information right away. So I was just curious what your experience was. If you found that using a generic plan would be okay, or it looks like you had very detailed information for each of the locations, and you were actually able to utilize that information.
Yeah, I'd say because the scale of like the DTA projects you're working on are considerably bigger, and I think that more generalized timing plans work well when you're the type of output that you're trying to get. When we're trying to look at specific queue lengths, do we need to add a turn lane? Do we meet the regional mobility targets on VC thresholds? And the scale of the model we have, then at that point, really, we do need to go down to we have to have the real timing in there, you know, as if you were doing a synchro analysis. And then ultimately, we need that same level of timing for the vSim model as well. So, and we're effectively using the same controller between the meso and the micro.
Randy, we're at time, but there is a question in the chat from Jin Ren. Do you want to take that quickly and then we can move on? My chat is not showing up. So if you could read that to me, I'm happy to answer it. Jin's question is ICA an intersection delay based assignment approach, or how does the Meso model take care of link delays? Sure. So ICA, intersection capacity analysis, instead of using a traditional volume delay function,
your impedance essentially comes from the delay results from that intersection capacity analysis. And so we ran ours using HCM6 methodology, but you could certainly run other methodologies as well. Okay. Well, let's go ahead and move on to our next presenter here. Get my screens organized.